Alright, so this will be a video where we're going to try to answer the HSC question of why do we use CAD? CAD, computer-aided software, or why do engineers use them? What is the advantages and disadvantages of doing that? We're adding this, this is going to be done in our braking part of the syllabus, so we're going to be using a brake as my example. So this is a brake, a disc brake. If we look at technical drawings for disc brakes, this is what we imagine it looks like. And if you're drawing this yourself, for example, this one over here, if you had to make this particular disc brake over here, the outer circles shouldn't take that long. You just get a protractor, you do that circle. The inner circles will take a bit of time because you got to like draw each individual circle, and you can get very, very good detail with a hand drawing, but it will take longer, and repetitive tasks physically take the same amount of time to do it. If I was to draw one circle, or if I was to draw 100 circles, it's going to take 100 times longer. We see here with this image, there's a lot of things that have a pattern, and so we're going to try to use those patterns to do our disc brakes. So this is one of the CAD softwares we have, Fusion 360. I'm assuming this point you've downloaded, have a student account, and you probably even have a basic understanding of Fusion 360 at this point. But so it starts with an empty canvas. When we do Fusion 360, we have to start by making 2D flat objects and then make them into 3D. One disadvantage here compared to the real traditional technical drawing is real hand technical drawing. You can start with the 3D object already. If you know how to draw a cube in 3D, you can already start doing that drawing. So for some of those, that's an advantage. A disadvantage of CAD, you have to, depending on the CAD software, Fusion is an additive software, so we start with a flat surface, and then with that flat 2D surface, we turn that into a 3D surface, and then we add more and more features to it. So if we want this disc, we are going to do a circle. We'll sketch on this plane over here, and I'll press the circle button. We have to define we have to start defining things in CAD. So we define where the center point is, and as we drag it out, we can pick a distance. Depending on the CAD software, so when we have our CAD, we can change the dimensions of our object that we want. So it's not good for sketching, and I did quotation marks there. It's not good for sketching as for just thinking of an idea, because you've got to give it an exact distance. If you just want to get a rough idea about shapes or how it looks compared to other things, that is still better by hand. So most initial concept sketches are still done by hand. The CAD uses the term sketch, as in this is, as you see in the top right-hand corner, it says finish sketch, but it wants your very precise details. So CAD is still not used for the very first initial phases of design. It's still usually done by hand. You have to have some sort of understanding about the sizes you want. So this disc brake, and I'm picking random numbers here. I want it to be 150. As you see, I can press the number 150 in here. One advantage of CAD, if I put in 150 there and I press enter, this circle is as close as my CAD software can make this circle to 150 millimeters diameter. It's assuming I've set this up in millimeters. Obviously, you can set up into different sizes, and you can change that different units. But it's as accurate as the CAD software would let this be, which most modern CAD softwares is as accurate as drawing. But it's not infinitely accurate. It still has to get that data into a computer, whatever number system the computer's using, which is only accurate to a certain decimal place. So you will get artifacts that come out of your particular CAD drawing. If you have two lines that we know these two lines overlap, depending on how they're drawn on the CAD software, they might be some minute distance apart, which could cause issues when it comes to like selecting a shape. So I have this for my disc brake. Cool. I can press finish sketch. I have my 2D shape. In this CAD software, I can press extrude. I can press my surface over here. And when I press this profile, I can click and drag. Fusion 360, like most CAD softwares, will have something like this. An advantage of the CAD software is if I don't know how thick I want this, I can drag this and I can visibly see the size here. You don't have that option in real world. You'd have to like visualize how thick you'd want the piece. You might be able to look by other products, like you look at how thick the table is in front of you, or you use a ruler or your hands. But CAD does allow you to measure that. And you can also pick a very precise thickness as well. So let's say I want this to be 7.5 millimeters. I can do that. CAD also allows you to pick some CAD softwares like Fusion, allows you to even use formulas. So if I have 10 millimeters, but I want this to just be I want this to be 2/4 of 10 millimeters, I can times it by 3/4. And you can put an equation, and Fusion does, and most CAD softwares, you can put the equation right in there. Useful if, for example, you're making a fence post and you know you have 10 meters and you need one fence post you need 7 fence posts. How far away will they be? You go 10 meters divided by 7, it'll automatically do that distancing in there. I personally use it only when I'm doing some sort of distance that's going to be a reciprocal, like 1/3, because if I'm putting that in decimal, it's not going to be very accurate, but I can do 1/3 and then it will do it as accurate as the input box will allow. I have this circle here. It's a disc. I can then modify this to make the hole in the middle. So I can do another sketch out here, and then I can drag this length, so 600, press OK. CAD is an additive software, so it allows me to edit this. Once I have this shape, I can do the opposite of an extrude. I can make a hole, and so now I'm modifying my CAD piece, right? So far, this is something that's still easier to do with your real world drawing, because I've just drawn 2 circles, but it's taken me more time to do that in CAD. So let's do something that is going to be faster to do in CAD than in the real world. So with our drawing that we had, I want to try to do these little holes over here. Now these little holes are coolant holes or whatever I believe they're so if there's water inside the brake pad, it doesn't get stuck between the brake pad and the brake disc. The water can flow through the holes, and it also allows some airflow to travel throughout it, so it enhances the cooling. And I believe a real disc brake also isn't one solid piece of material. The real disc brake is hollow in the middle as well, so it allows for more cooling for that part. So for us to do this, we'll show you how like a fast CAD person would do it. We can sketch on this surface. We know our holes are going to be here. Our holes have some sort of curvature. Let's say they go like this. Press my enter button, and now what I'm doing here is I want to make the curve that these particular holes will follow. All right, so this is the curve that I want these, those 4 holes we had there, I want those to be along that curve. I can then go sketch, actually no, sorry. I'm going to edit the previous sketch I had. Edit sketch. I'm going to hide this body, we don't need that. I want this hole to be 4 millimeters, and so now I have this hole here. Now I can just draw this hole along this path. CAD allows me, if that's a good path, I can make a new circle. As I bring my mouse to the circle, it changes the symbol. So that means in this CAD software, it's saying your next circle, I want it to follow that line. So good if you have a particular constraint. Very good if you have something symmetric, or if you want to have like you're making windows or whatever, and you want the bars to connect to a certain part of the window, it can follow previous constraints. But we can also do a pattern. It's not going to let me do that pattern, maybe not. Okay. What I will do is, what's the fastest way to do that? Not this. I have this circle, And then I'll go to create and I'll do a pattern. And I'll do pattern along a path. And I will press maybe I have to turn this in. Maybe I have to turn this into on the body first. So I want to cut the hole into here. I want to make a hole over there. So what I'm going to do is I'm going to hide this, extrude. I want to drill that hole into. I want to drill that hole into the body that I have there. And if my CAD's okay, yes, so I want to drill that hole through that body. And I can do that in my CAD software. I can go to modify, I can select this body and I can say this second body, which is the hole, and I can say remove, and then it's going to target body is this. Yep, and then that's our. Okay, so if I press this OK button, it's removing that hole from the body. So I've got it from the disc. So I just got to do this, and I just got to draw this like 1,000 times around. But this is where CAD is going to be faster. I'm going to undo what I just did there. Instead of just having one hole, I'm going to use some tools now to try and make all these holes. So I'm going to unhide my previous sketch. I'm going to create a pattern along a path. I'm going to select pattern along a path. I'm going to select this body. The path I'm going to select is this one. And if I drag this line over here, I can make these holes and quantity. I can even make it 4, and then I can press OK. And then, so now I've made 4 of them, and those are 4 holes along that line. And I can even go one step further. I can also press create, pattern, circular pattern. I can select these 4 bodies. I can choose to rotate them around like that, and I can make. So now this is where I've made, what's 4 times 15 is 60 holes, basically instantly. I've made these 60 holes in my brake, and I can then do that step I did previously, modify. This is the body. There must be because that is it. And then all I have to do is select all the other bodies over here. Should say 60. Yep, and I want to cut it. And now we have all the holes inside our brake. So that would take, that's one advantage of CAD. When you're doing a lot of repeated actions, it takes 2 minutes. Otherwise, if you're doing that by hand to get them exactly as accurate as you want them, it's going to take a lot longer to do these repeated actions on this brake. Okay, so next thing, before I continue the next part, I'm going to have to make something else on my brake pad. I'm going to have to make the brake pads to go with the brake disc. So let's just say for this simplified scenario, it's just going to be a nice little circle over here. I just got to select all these individual holes that we had here. Okay. This will be the caliper. This is going to be the brake pads it's pushing onto the disc, and this particular one, I want this to be a new body. Okay. So I have this. This is my two parts. This is a very simple, rudimentary version of our brake pad. I can then make a copy of this as well. So another advantage of CAD is I can press the once I have my object, I can select this object over here, and then I can just create a copy of it. And my copy I can move my copy over here. What distance is it? 0.85. Okay, so making copies of objects is instant in CAD, so it's an advantage of CAD as well if you want to copy a particular object. Moving a particular object is an advantage of CAD over drawing. Every time you move it, you're going to have to change it. Also, rotating your particular object around to see different views. So if I want to see how those discs look on the top view, I can do that in CAD very, very easily. Let's save this. Save. Okay, so other things we can do with CAD. I like this design. Let's say this is an amazing CAD thing. I can also put material properties into an object. I can make this inner part of the disc. Let's say I make this, I'm going to make this aluminium. If it loads up. It's very slow. Okay, so most CAD softwares, Fusion is one that has a lot of materials. So you can actually physically change the material, because we're going to do a simulation if we have time. I'll run a simulation. But also you can just change the appearance of materials as well. So let's just say I want to make this aluminium, so I can click and drag. I can make that part of this aluminium, and if I go through and let's see if I have steel. Not stainless steel, just steel. I can even pick my particular type of steel. This, I want this part to be steel, and I want this part also to be steel. So I've now added these elements into my design. They're going to change things like the so I want to know how heavy this is. Say I'm making a race car. You can mathematically find that out by hand. You can find your area. You get your area of your big circle minus about all the circles you've removed from it. Or we can press the right click this body over here, If we right click it, eventually. I'm trying to remove the mouse. Maybe the mouse is messing up. Right, if we can look at we can press the properties, and then we can see the properties over here. CAD instantly most CADs have features where you can instantly calculate stuff like volume. So the accuracy is not necessarily better than the drawing, because people do with the drawing typically are doing pure mathematical numbers, so they can do like pi in their equations. CAD softwares are doing it based on the accuracy of the software. So, but it can find the area, and that's surface area in this case, density 0.03 grams per meters cubed. I don't think that's aluminium, is it? Oh, per millimeter cubed, probably. That might be aluminium then. So it shows the mass. That disc brake, right there, I know that's going to be 283 grams. So let's say I'm doing a racing team, and we want to try different things for the disc brake. We can change our mass, and so we know the weight of that particular component. We can find that quite easily. When we did it at 7.5 millimeters thick, if you were to go back and change it to 10 millimeters, you can redo the analysis and it'll tell you what that new mass is. Same with the volume, and in this case it's telling us what the material is, but we can also find things like center of mass and moment of inertia. So all these things that are going to affect our other equations, we can find that out fairly easily with CAD. So the next thing we can do with CAD is, once we have our 3D object, making a drawing with it. Making a drawing with your CAD, because you've invested time into making a 3D model. You don't actually have a drawing yet. We aren't actually at the point yet. Where we have a drawing that looks like this. We don't have this yet. We have a 3D model. I can't give this model to a producer for them to make this particular design. But once we have it, converting it is quite quick. It has to save the model. I'm saying I want to bring this model in for a drawing. I think it's recording. Yes, okay. All right, so once you load it up, you have the object, and then you can choose where you want to place it. This is where you're choosing when you're doing your drawing, where you want it, but I have mine. That's the side of the disc brake over there. I can put in my scale, I put in my page, you have all this stuff you can fill out. But then once you have it, actually drawing the views is really, really quick. Well, at least as fast as your computer can do it. You're still expected to like align these all correctly, how you want it, but when you just press the enter button, they've all rendered all the drawings. Cool. You can also do features. I mean, I haven't done the automatic. I don't like the automatic dimensioning, but we'll see what happens here. You can pick dimensions, and then you can even click it like that, and it should do, this isn't, Fusion is an American company, so it's not, Autodesk, so it's not doing all the dimensions to AS 1100 standards, right? So if you're an architect or an engineer and you're expected to do it to an AS 1100 standards, you'll have to modify those particular dimensions, how they're presented. For example, this is in, I think this is in third angle projection, I think. But we can still find that stuff. We can then, oh, sorry, let me zoom in. We can do things like we can find how far away this is to that by clicking these sides. So we have these dimensions, and these dimensions are going to be pulled, this 49.5, that's in millimeters from your original drawing, not the drawing on here. So you can do that. You can also add features. So this would take just as long in the real world, actually doing the dimensioning, because doesn't take that long to actually do the dimensioning in the real world. But it's pulling it from the model. So where this is relevant is once you have all these set up, if we go back to the original model and we change a dimension, we can update all of our drawings in here and all the things will change. If I made the discs larger, all of it will update and it will change in this sketch. So anytime you have to do changes, which is obviously changes happen in the design, so advantage of CAD is as you start changing designs, it will automatically do all the other changes for you. That will show. That could also be not necessarily a downside, but a bit of an issue. Anything you change early on in your design, you got to account for how that's changing further down the line. When you start doing a project where someone's doing the drawing of like the brake, if you change your model because you're testing a new model, you can ruin their drawing. Not ruin because like they need to get the most updated version of the drawing. So if you're doing a teamwork, this is where it's important you have like versions. So like if you're doing a minor change, you can keep it in the same version. But if you're changing it to like four brake pads instead of 2, you should change, maybe copy and make a new model with that. Okay, so we have this, and sure, I can save this as well. 20 minutes. Disc brake preview drawing, wonderful, cool. Save this, close this. Now these next two things, I'm going to do a render and a simulation. I don't know if they'll finish by the end of this class, but I'll start doing them at least. I have my model here. I want to make it look nice and pretty because we're trying to show off this car to an investor maybe, or I know the executives. And if they're not engineers, they want to see something that looks nice and flashy. Or maybe you're making this particular model for a video game, or even like Airbus, when they make their airplanes, they have to make them look graphically good. So we can go to the render. And render is when you get a 3D object over here and we try to add in all the things that make it look realistic. Either we put a texture on it. Video games have heard the term ray tracing. Ray tracing has been around in CAD software since its initial, CAD softwares. The difference is if you're NVIDIA and you are doing ray tracing on your Cyberpunk video game, it's happening like 200 times a second. In here, one image is going to take like 15 minutes. So ray tracing, it's trying to get every single ray of light, how it's bouncing off all the individual objects. Every object has a different amount of light it's absorbing. It's also reflecting different light. So a green object will reflect green light. So in this CAD software, I can move this around. I can zoom it in. I can do all that stuff. But for this task, let's just say we have a disc brake like this. Yep, we know there's slow performance. Thank you, Fusion. I can just press the render button. I'm going to start the render and hopefully it'll be done by the end of the lesson. Render. I'm not going to do final quality. Let's just go standard. And let's not do that image size. Let's do that. And because this is a student account, unlimited, you should also have unlimited. If you are using the free trial account, you're not going to have unlimited tokens for your thing. Fusion, modern CAD software, they have some sort of cloud rendering. Other CAD software might render it on the computer. So if you have a very beefy computer at home and you're deciding not to play Fortnite on it that night, you can render your stuff on your computer. It means you have advantages like you don't have to upload your stuff. If you're a company like Boeing, you don't really want your big sensitive data to be sent to another company, because then your new designs can be hacked or whatever, and somebody can steal your drawings. So you might want to invest in having computers that can do the CAD yourself, the rendering. So I'll press this render button, and now it's going to make this into a nice 3D object. You don't really have that option in the real world. So this is an advantage of CAD. You don't really have the ability to make a drawn version. You'd have to go to an artist, and they'll have to give you their artistic interpretation of what the light shining on the object would look like, or you make a physical prototype. So those actually are the analogies, and they take a lot of time. This will take approximately, it said 10 minutes. So that's good. Let's also do a simulation, is another good thing the CAD software can do. So we have this disc brake over here. We can see what happens as we push the plates onto the disc brake. We're producing friction, so that friction is going to be something affecting the rotation on this particular device. Let's just do a static stress, create a case study. Let's see how fast we can do this. So we want to simulate what the stress going through this particular disc is, so then we can find where cracks would likely form in this particular object. So constraints, structural constraints, let's say we want something to be fixed, so model components, here we go, yes. And we want automatic contacts, generate. So we made some contacts. Okay, now let's put a load. Let's do a, let's say we add a moment to this target over here. I don't know the value, so I'm just going to put 1,000 Newton meters. Maybe 100. We'll just put 100 and we'll see what that looks like. Okay, there's a moment on that face going that direction. We should be able to solve this now. Solve. So what we're doing here, we're just seeing if I was to twist this disc brake 100 Newton meters, how it's going to be affected. And then I can run this study. And it's the computer's analyzing there, it's doing all these stress calculations. We've done some basic understanding of stress and strain with our calculation of, what is it, stress equals force over area. It's doing these on a very tiny level. What it's doing is it's actually approximating, if I show this in the mesh, it's approximated these into heaps and heaps of, can I see the mesh? Here we go. Let me see if I can show you the mesh. That might be a bit easier to understand. It's not loading up. But a mesh is where we're assuming this is like heaps and little tiny triangles, and it's basically one big, sort of like one big truss analysis, sort of like one big stress calculation, one big simultaneous equation to see what would be the amount of force going through each individual element of this disc brake over here, And the actual name for that is FEA, standing for Finite Element Analysis. So we're choosing how many times you want to simulate this object. Now, while this is happening, let's see if our render has finished. I think our render is finished. We can look at this over here. So there we go. There's our very 3D and shiny looking disc brake. And that's an image file. Fusion doesn't display it the best, but I can, you can put that into Paint or your document or whatever, you can download it. And so we see here when it made this particular disc brake, it shows that the aluminium was nice and shiny. It's reflecting the light off the parts of the disc brake. You can add colors into that later on. And do more things, but it's rendering's a term is to bring color or to make it look into the real world. So we can do that. It's CAD. We can also, I'm not going to have time to do it here, but we can use CAD to show animations to show how particular parts in a CAD move. We can also do CAD for manufacturing. We want to put stuff onto a CNC machine. We can put our CAD object. We need a 3D object for our CNC machine to follow, and that's how we can get nice curvatures and stuff like that in our CNC machines. This particular CAD also does electronics, but I don't know anything about that to tell you. And now let's see if we have if the simulation is complete yet. Looks like the simulation is complete. Did any of it work? No, we don't want load case. We'll close. We want stress. Oh, nice, cool. So if we had that disk, turn around, look at this one. So we've our disk over here. If we put a moment twisting on the disk over here, we can see where in the disk, if we put a moment here twisting, it's exaggerating it, so it's easy for us to visually see where the issue is, because if we change it to be, not that, sorry, how do we change it? If we change the deformation to actual deformation, that's how much it's actually deformed. Barely, none. But CAD, and even when you do a real experiment, you need like a, what is it, magnifying, no. Not a magnifying glass. What is the thing that's used in science to zoom in with your magnifying? Microscope. Yes, thank you. Microscope. You have to look in a microscope to see these minor details. But CAD, it's just a number. We can get it to amplify that so we can see actually what's happening. So as this disc brake is twisting, it's slightly deforming. It's slower near where this container is. So where the pads are pushing up against it. And so then you can see where the most stress is. I picked an arbitrary number of 100 newtons, but let's say you have a race car and you know how much, when we did that braking question we did here, we know how much we need the brakes to perform for our car to reach a certain performance. And we divide it by 4 brakes, so we can then see the actual material, how much will our actual aluminium deform. But then we can also see, all right, where it's the most red, right, where we can eliminate all this low pressure stuff, right? And we can say just where it's the most, that's where it's most likely to crack. That's where the most stress is. So then when we inspect our products, if we're like an airplane, when our airplanes come in for inspection, we say, oh, you should look at these particular holes on the disc brake because these are the ones our testing. So our CAD has determined is the part that's under the most stress. So these are the parts that are most likely to break first. So that's another good advantage of CAD. It allows you to do finite element analysis, which can then do things like find out where the most stress on the object is. One One thing I haven't shown you, but you can do many things with FEA. I'll probably do another lesson showing more examples of FEA. You can do things like see how the vibrations happen. You've seen in music or in science, you have the tuning forks where you shake it and they do a particular sound. That's called a resonance frequency. And you can find out the resonance frequency of your objects, which means you can then find out where they're likely to break. You can also do other studies like thermal, see how the heat is precipitating, or maybe that's not the right word, but see how the heat is going through the particular object. There's also fluid analysis as well, great for aerodynamics, for like airflow going over particular objects like race cars or aeroplanes. But even on a larger level, when you build a new skyscraper now in Australia, you need to do fluid analysis of how the air flowing through the city is going to be affected by your skyscraper. So you might have to like change the size of your building to see how the air is going to flow through the city. And you can do those analysis. To do those analysis, you first have to model it in CAD to then get it to the point where you can do those 3D models. You can also do things like dynamic tests. You may have seen some CAD drawings of like a ball going through a wall, or what's the Facebook meme right now? It's like you start with one tile going through an object, and then it's 4 tiles, and then 16 tiles, and it does like the blanket falling onto the object. That's done in Blender, which is similar. Blender's a form of a CAD software, and it has an analysis connected to that as well. So all those are things. The ball one is a silly example, but you could use that if you're designing like bullet resistant glass, or you're designing a car to see how it happens under a car crash, and you emulate the car going into a wall. You see how that force is going through your objects. I think that's it for the CAD, for at least what we have at this particular lesson.